What are conic sections? Well, why do we call them conic sections? What section of a cone is it? I'm glad you asked. Welcome to Mr. Reader's Kitchen. Today we're going to talk about conic sections and why we call them conic sections. So let's begin by putting on our aprons and preparing to slice a cone in order to demonstrate why we call them conic sections. I have here a styrofoam cone. Let's begin without even cutting. It should come all the way up to the top, but this is actually a truncated cone because, as we can see, there has been a slice taken out of the top of this parallel to the bottom, and what shape does it create? A circle. So when we slice a cone parallel to its base, we get a circle. We're going to have to do a little more cutting. So let's get a cutting board. Let's get a knife and let's begin slicing. Let's suppose we wanted to create an ellipse. Instead of having a circle that is cut parallel to the bottom, we can cut sideways. And in so doing, very carefully, we have cut an ellipse. This is not a very pronounced ellipse. It's almost circular because it was only done at a slight angle. If we did it at a more pronounced angle, which I'm about to do, then we would have a more elongated ellipse. So we're going to do that. Let's cut it at a bigger angle. There we go. This is an ellipse. And we get that from slicing a cone in a fashion that is not parallel to the bottom. Just at, ooh, I dropped it. Just as when we cut this portion off, it was not parallel, and this was even less parallel, if we can make those comparisons. When we did that, we created a very elongated ellipse. Let's suppose we wanted to cut in a fashion that is parallel to one of the sides. For example, if one of the sides is going like this and I cut like this, what shape would that create? This is going to be very hard to do. But we're going to cut in a way that runs parallel to one of the edges, if I can keep it from falling over. This is not the right knife for the job. But they don't sell styrofoam cutting knives in cooking stores. Either that or I need to sharpen the thing. This is quite difficult and slightly embarrassing. There we go. Kind of chewed through the bottom of it. But when we cut it parallel, like my hands are parallel, the way we cut, this creates a parabola. Now parabolas and hyperbolas look very similar, so it's easy to mix up the shapes. But a parabola does not have asymptotes on the side, and a hyperbola does. Well, how do we get a hyperbola? All we have to do is cut perpendicular to the base, and when we cut perpendicular to the base, we get a hyperbola. Now I realize that that is not very pronounced in its corners and it looks a lot like the parabola that I cut. But when we cut perpendicular, it does create a hyperbola. There are asymptotes here. I'm going to cut one more time, perpendicular to the base, and this one should turn out a little bit better. Or not. Cutting perpendicular to the base creates a hyperbola. Take my word for it. Thank you for joining me in my kitchen.